Hello there, and welcome back to the Sleep Science. Tonight, you're not floating in a bed or even on Earth, you're adrift in a darkness so complete it almost hums. There are no stars yet. No galaxies, no comforting moonlight reflecting off forgotten oceans. Just a silent, formless expanse where time itself seems undecided about whether to move forward. You probably won't survive this part, not because of danger, but because there's nothing to breathe, nothing to stand on, and definitely no coffee. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. Drop a comment with your location and local time. I always love seeing where the night finds you. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You float through a universe before it knows it's a universe. It's been just a few 100,000 years since the Big Bang, a blink cosmically speaking, and everything is still shimmering with leftover heat. The temperature hovers around 3000 degrees Kelvin, but there's nothing like a campfire to feel warm beside. Instead, the heat is spread evenly, an invisible soup of hydrogen and helium atoms finally forming after ages of chaos. You drift among them like a ghost in a fog made of the simplest things possible. Historians of science still argue whether the phrase "the dark ages of the universe" does justice to this era. There's light, technically, the fading glow of the Big Bang itself, but it can't travel far. Every free electron scatters it, turning the cosmos into a dense glowing mist. It's a bit like trying to see across a sauna, except the sauna fills all of space, and you're mostly hydrogen yourself. You might imagine a faint whisper of that light still echoing through time. That's the cosmic microwave background we detect today, the universe's oldest selfie. Somewhere in that deep and uniform glow, quantum randomness still leaves fingerprints. Tiny variations, fractions of a degree in temperature, dot the otherwise even subdintant sky. These are the first murmurs of structure, faint hints that gravity will one day have something to work with. You glide between them, noticing that some patches are just slightly denser, ever so slightly heavier. Those slight imbalances will become everything. Stars, planets, you. Imagine that. The whole of human drama and cat memes condensed in a decimal point of cosmic unevenness. The air, or what counts as it here, buzzes faintly with photons that have been travelling for 380,000 years since the Big Bang first flared. Before this moment, those photons couldn't move freely. The universe was a blinding plasma, opaque as foggy milk. But now, as electrons find homes inside atomic nuclei, the cosmos becomes transparent. The light escapes. The first true darkness descends. You drift, and the silence is enormous. There's no sound because there's no medium thick enough to carry it. Still, if silence could speak, it might sound like a distant hum, the stretching of space itself. It's expanding, slower than before but still relentless. Every cubic meter of nothing grows larger every second. You reach out, metaphorically, because, again, you're made of theoretical stardust and poetic license right now. And feel the distance between hydrogen atoms widening. Expansion is patient but unstoppable, a fun tidbit most people never hear. Hydrogen atoms are weirdly social. Even in this emptiness, they occasionally collide and form molecular hydrogen, H2, the simplest possible molecule. These fragile pairs will one day become the raw material for the first stars, but for now they just float, bumping into each other once every few million years. It's the slowest dance imaginable, and yet gravity is waiting in the wings like an anxious stagehand. Invisible dark matter, 5 times more abundant than normal stuff, has already begun clumping in unseen halos. The atoms can't see it, but they feel its pull, ever so slightly drifting toward its ghostly gravity wells. Historians still argue whether dark matter's role was purely structural, or if it seeded the earliest galaxies in more complex ways. But you can feel its tug even now, like the faintest current beneath still water. You move through eons in moments. Hundreds of millions of years pass while nothing seems to happen, yet everything is preparing. The density variations grow. The cosmic background fades into cold radio whispers. The darkness deepens until even metaphor feels thin. The temperature drops to just a few tens of degrees above absolute zero. Somewhere you might imagine the first murmur of time itself slowing its breath, waiting for light to return. It's strange, isn't it, that the universe had to learn stillness before it could learn brightness. The first light that wasn't born of chaos won't appear for another 100 million years. Until then, this silence reigns. You feel a peculiar peace in it, a sense that every molecule, every potential atom of your future bones is patiently waiting in the wings for its cue. A stray thought crosses your drifting mind. What if it had stayed dark? What if gravity had never found its rhythm? If the atoms had never gathered? Historians still debate how fine-tuned those early conditions were, whether they were pure luck or a sign of deeper rules. Maybe the universe always intended to wake up. Maybe it just stumbled into consciousness. Either way, here you float, between what never was and what will soon be. If you listen closely, you can almost hear the faint whisper of hydrogen atoms talking among themselves, plotting their slow rebellion against the void. They don't know it yet, but they'll be the first to light the stars, to forge the metals that make planets, to form the neurons that someday wonder how it all began. For now, they are just drifting thoughts in a cosmic mind not yet awake, and you drift with them, a spectator to a birth that hasn't happened yet. The darkness presses close, not menacingly but protectively, like a blanket around something fragile. The first galaxies are still only dreams, their light unborn, but somewhere in the heart of gravity's slow patience, the quiet birth of everything is about to begin. You keep drifting, as darkness begins to stir. It's not a noise exactly, more like the universe taking its first slow breath. In the endless black faint ripples move through invisible matter, carrying the memory of those tiny temperature imbalances you floated past earlier. They were almost nothing, just one part in 100,000, but gravity loves an underdog story. The slightly denser spots begin pulling more gas toward them, and the more they gather, the stronger they become. You watch as the first cosmic neighborhoods start forming, clusters of invisible matter cradling clouds of hydrogen, like a patient hand holding water. This is the moment when light begins plotting its comeback. Those ripples you noticed earlier, the leftover fingerprints from the Big Bang, now guide the flow of matter across unimaginable distances. You might picture it like a vast cosmic topography with invisible valleys and hills where gas will one day collect. The peaks and troughs of this ancient energy map are still visible today in the cosmic microwave background. That faint static pattern astronomers adore. When you hear about satellites like COBE, OMAP or Planck, this is what they were studying, the faint pattern that decided everything's fate. Historians still argue whether we should call these ripples the first blueprint of the universe or simply the residue of chaos cooling off. But either way, you can see their consequence. Where there's slightly more mass, gravity flexes and the fabric of space dips inward ever so slightly. The first filaments of the cosmic web begin sketching themselves across the void. It's not a web you could ever touch. It's made of dark matter, unseen but all-important, the scaffolding upon which galaxies will grow like dew on a spider's thread. You drift closer to one of these embryonic filaments, and the hydrogen there feels different. It's thicker, if something that diffuse can be called thick at all, and it glows faintly in the ultraviolet, invisible to human eyes but dazzling to your imagination. Each region of slightly higher density will eventually become a galaxy, though right now it's just a cold collapsing thought. You can sense time moving faster now, or maybe you're just finally aware of it. Millions of years roll by like seconds as gravity continues its quiet work, gathering clouds and tightening its grip. A quirky tidbit from modern astrophysics. Some simulations show that sound waves, yes, literal acoustic ripples moving through plasma, once shaped these early formations. They are called baryon acoustic oscillations, and that they still leave a faint pattern in how galaxies are arranged even today. So in a very distant poetic sense, the universe once had a heartbeat, and it still echoes faintly in its bones. You almost want to lean closer and listen, but sound can't travel through emptiness anymore. Still, if silence had rhythm, this would be it. As you drift, you pass through one of those regions where gravity has begun to overachieve. The gas inside grows denser, spinning slightly as it collapses. Pressure builds, and the temperature climbs toward thousands of degrees. If you could see it, if your eyes weren't hypothetical, it would look like a faint red mist, glowing from within. The first stirrings of starlight are almost here, and it feels like waiting for a sunrise that's 100 million years late. Historians still debate the precise timeline of what's about to happen. Some say the first stars flared to life roughly 50 million years after the Big Bang, while others suggest it might have taken twice that long. The data are faint, buried in the farthest reaches of telescopes that strain to glimpse the edge of time. What everyone agrees on is this. Those first stars, known as Population 3 stars, were unlike anything you'd ever see in today's universe. But before they arrive, the universe needs structure. Dark matter halos deep enough to cradle those future stars. You hover at the edge of one such halo, a ghostly bowl of gravity tens of thousands of light years wide. It's invisible, yet you can feel its pull, like standing near the ocean and sensing its undertow. Gas flows inward along filaments, collapsing towards the centre, heating as it goes. A cosmic traffic jam of atoms builds up, and in those congested regions, the temperature spikes until something miraculous becomes inevitable. You might think of it like dough rising in a slow cosmic kitchen. The ingredients, hydrogen and helium, are simple, but gravity is the yeast that makes everything expand and take shape. It's patient, relentless, and slightly smug about the whole process. Eventually, the density becomes so great that the collapsing clouds start fragmenting, forming smaller clumps within clumps. Those clumps are the cradles of the first stars. You pause for a moment, watching one region pulse faintly with infrared light, barely visible, but undeniably alive. It's like spotting the ember of a match before it's struck. This is where the quiet ends. Soon, fusion will ignite, and the first real light since the Big Bang will burn across the universe. It's humbling to realize that every galaxy, every sun, every warm morning sky owes its existence to this invisible choreography of density, heat, and patience. A curious note from modern cosmology. Even though this era is unimaginably ancient, we can still see it. When astronomers point the James Webb Space Telescope at faint red smudges more than 13 billion light years away, they're looking back to these very moments, the universe's awkward teenage years. Some of those smudges may be the earliest known galaxies, mere clusters of newborn stars gathered in dark matter cocoons. Others might just be gas clouds that never quite made it to stardom. Historians still argue which is which. You drift one last time through the thinning darkness, and for the first time you feel a tremor in the silence. Gravity has gathered enough mass. The cosmic soup has reached the boiling point. Somewhere ahead, hydrogen atoms are colliding so fiercely that their boundaries blur and nuclei begin to fuse. Energy will soon pour out, bright, lethal, beautiful energy. The quiet universe is about to speak in light. And just before that first flash, before the stars awaken, you can almost hear the cosmos hold its breath. Everything that will ever be is balanced in that pause, waiting, weightless, and infinitely patient. You barely notice when the first photons break free. It starts as a pulse, a shimmer in the dark, a quicksilver flare rippling through hydrogen fog. The silence of the cosmic night fractures as fusion, the most elegant form of alchemy, finally begins. You drift closer, feeling the weight of gravity's long patience finally rewarded. In the center of those collapsing gas clouds, temperatures have climbed past 10 million degrees. The simplest atoms, hydrogen nuclei, crash together so hard they merge, becoming helium. The reaction releases light, heat, and a new kind of permanence. A star is born. You watch it bloom, enormous and ferocious. These first stars, Population 3 as modern astronomers call them, are nothing like the cozy suns you know. They are titans, hundreds of times the mass of our sun, burning white blue and living fast. Their gravity is immense, their light savage, their lifespans tragically short. Most will burn out in a few million years, a blink compared to the cosmic calendar, but in that blink, they will remake everything. Their ultraviolet light cuts through the surrounding gas, carving bubbles of brightness into the dark. The universe begins to glow not from background radiation, but from its own newborn stars. You drift around one of them, trying to take in its scale. It's vast. If it were at the center of our solar system, its outer layers would reach past Mercury's orbit. The surface roils, luminous and violent, a sea of plasma churning under impossible gravity. You can almost feel the light pressing against you, so strong it would shred any solid matter in seconds. Yet somehow it's peaceful too, a first note in the grand symphony of starlight. Historians still argue whether these colossal stars formed singly or in groups. Some computer models show them hatching alone, each dominating its own region of space like a solitary monarch. Others suggest they were born in small clusters, gravitationally bound siblings sharing a nursery cloud. Either way, they didn't last long enough to grow old. Their death, when it came, was glorious, a supernova that briefly outshone entire galaxies. You can sense the first of those deaths now, somewhere not far away. A massive star collapses under its own weight, its core imploding into iron, then rebounding in an explosion that hurls new elements into the void. For the first time, the universe is seeded with metals: carbon, oxygen, silicon, iron. You feel a faint satisfaction knowing those same elements will one day form rocks, oceans, and you. Every breath you've ever taken was forged in this furnace. It's strange to think that the most peaceful night sky owes its beauty to such violence. The first starlight isn't gentle, it's harsh, tearing apart molecules, stripping electrons from atoms. The ultraviolet radiation creates vast ionized bubbles in the intergalactic medium, spheres of light expanding outward like cosmic soap bubbles. Where they overlap, the universe begins to clear. The fog thins, the great reionization of space has begun, though it will take hundreds of millions of years to complete. A quirky tidbit: some astrophysicists believe that dark matter, usually the quiet, invisible type, helped shape these first stellar nurseries by forming small, gravitational wells that funneled gas toward the densest spots. In other words, dark matter wasn't just the scaffolding, it was also the midwife guiding the gas where it needed to go. Without it, there might never have been enough density for the first stars to ignite. You can almost imagine dark matter as the shy backstage hand making sure the spotlight hits just right. As more stars ignite, gravity begins learning a new trick: coordination. Clusters of newborn suns tug on one another, merging into larger systems. The first proto-galaxies appear, small and irregular, glowing like fireflies in the early night. They're chaotic things, collisions everywhere, bursts of light and gas flung in every direction. You drift through one, watching stars form, die, and be reborn in endless cycles. The air, if you could call it that, is full of ionized hydrogen, glowing faintly pink under the newborn light. It's both beautiful and terrifying, like a galaxy caught mid-thought. Historians still debate how organized these proto-galaxies really were. Some believe they were little more than turbulent gas clumps with a few bright stars embedded inside. Others suggest they already had primitive disks and halos, the skeletal beginnings of structure. The truth probably lies somewhere in between, a messy adolescence of cosmic architecture, learning through trial and error. You glance back over your shoulder, metaphorically, and realize how far you've come. Only a few 100 million years ago, the universe was dark and cold in matter. Now it's alive with points of light, each one a tiny rebellion against entropy. The darkness hasn't vanished, but it's losing ground. The cosmic web, once invisible, begins to glitter with filaments of faint illumination. You might even call it the first dawn. And through it all, gravity whispers, tireless and quiet, continuing to weave its invisible tapestry. Dark matter filaments grow thicker, binding galaxies together into embryonic clusters. The gas flows along those strands like rivers feeding a sea of light. The universe is still expanding, yes, but within that expansion, complexity blossoms. If you could take a snapshot right now, you'd see a universe in mid-transformation. Young galaxies glowing blue with newborn stars. The background still dusky with neutral hydrogen. You'd see chaos turning into pattern, emptiness turning into art. And you, drifting, timeless, impossibly small, would realize that this was the beginning of everything familiar. The light of those first stars is already fading, racing outward at the speed of causality. Billions of years later, some of it will reach telescopes built by creatures made from their ashes. They'll look up, measure the faintest flicker and say, "This is where it began." You drift deeper into this newborn universe, where the silence has become a soft hum of radiation and gravity's song. The first stars are fading, burning out in supernovae that flare brighter than anything before them. Each explosion sends shockwaves through space, compressing the surrounding gas and triggering new rounds of star formation. You hover among those shockwaves, feeling the rippling fabric of creation push past you, like standing beside an invisible tide that never quite ends. The universe, once a dark emptiness, now glows with brief, ferocious light. These early stars live fast and die young. They're cosmic overachievers, burning hydrogen at furious rates and swelling to monstrous sizes before collapsing in spectacular fashion. The quiet isn't gone exactly, it's just punctuated by thunder. You can almost hear the cosmic percussion. Boom after boom, the beat of rebirth. When each star dies, it leaves behind something extraordinary, either a neutron star dense enough to crush atoms into pure nuclear matter, or a black hole where gravity folds space so tightly that even light cannot escape. You watch one such collapse unfold, a sphere of plasma implodes, vanishes, and leaves behind only a shadow. That shadow begins to tug at its surroundings, feeding on the remains of its parent cloud. Historians still argue whether black holes formed first or if the galaxies came before them. It's a classic cosmic chicken and egg problem. Some theories say that the earliest black holes grew directly from collapsing gas clouds, skipping the star phase entirely. Others insist they were born from the corpses of those first massive stars, slowly growing as the galaxies around them evolved. You can't decide which story to believe, but both make sense in their own quiet, inevitable way. As you drift closer to one of these newborn black holes, you can feel the warping of space. Light curves, time slows, and gravity sings in a key that human ears could never register. The hole itself is invisible, but the disk of gas spiraling into it glows fiercely, white-hot near the center, fading to red at the edges. Matter falls inward, heating to millions of degrees before vanishing beyond the event horizon. This is the first generation of galactic engines, the seeds of the quasars that will one day blaze across the universe. A quirky tidbit for you: astronomers sometimes call these early black holes direct collapse candidates. Imagine a star so large it never explodes, it just shrugs and folds itself into infinity. Those direct collapses might have created the supermassive black holes we find at the centers of galaxies today. And if that sounds dramatic, it's because it is. These early monsters could have masses of 100,000 suns, yet fit within a space smaller than a solar system. You can't help but feel a shiver. Though it's more awe than fear. After all, even destruction here feels creative. The deaths of the first stars enrich the surrounding gas with heavy elements: carbon, oxygen, nitrogen. You glide through a cloud that's just been seeded by a recent supernova, and the air glitters faintly with microscopic dust. Each grain will one day become part of something solid: the crust of a planet, the ice of a comet, maybe even the backbone of a living thing, and for now, it just drifts, cooling slowly, waiting for gravity to call it home again. The universe is learning how to recycle. Historians still debate how efficiently those early generations of stars spread their metals. Some models suggest vast galactic winds carried enriched material far from their birthplaces, seeding future galaxies with the ingredients for life. Others argue that most of it stayed local, trapped in the turbulent maelstroms of early galaxy formation. Either way, you can see the results beginning to show. New stars, smaller and steadier than their ancestors, are forming from this recycled gas. They burn more quietly, more patiently. The first whispers of stability appear amid the chaos. You drift between them, these newborn suns, watching as they cluster together in irregular patterns. Some gather in loose associations, others form tighter, globular clusters bound by gravity. The light is soft now, not the harsh blue blaze of the first stars, but a gentler gold. You could almost mistake it for comfort, though the radiation would still sterilize any nearby world. It's the universe's version of a lullaby, brilliant, brief, and impossibly distant. As galaxies continue to take shape, the collisions begin. Clouds of stars and gas merge, swirl and tangle, forming spirals or ellipses depending on how they meet. You watch one collision unfold over millions of years, a slow-motion dance where two proto-galaxies intertwine like ribbons of fire. Streams of chips are torn free, forming long tendrils that glitter with new star formation. The aftermath is chaotic but beautiful, a reminder that even in the most violent unions, creation finds a rhythm. And somewhere within that cosmic ballet, black holes begin feeding again. As galaxies merge, their central black holes draw closer, orbiting each other in a slow spiral until they too collide, releasing gravitational waves that ripple across the universe. You can't hear them, but you feel them, a faint rhythmic pulse passing through the emptiness. Billions of years later, tiny detectors on a small blue planet will sense those waves and know that the universe itself can tremble. You pause, hovering in the aftermath of this celestial dance. The light has dimmed a little, but the structure is clearer now. Where once there was chaos, there's pattern. Filaments of dark matter thread through the growing cosmic web, connecting clusters of young galaxies like veins in a living organism. Each intersection glows faintly, a node of light and matter, a growing city in an endless night. the quiet birth of galaxies continues, not in a roar, but in a patient murmur. Gravity whispers, stars answer, and darkness gives way to form. You feel the weight of time stretching before you, countless eons of creation and destruction still to come. The universe has learned to shine, but it's only just beginning to understand what that means. You float in the hush that follows all that brightness. The light from the first supernovae has faded into a softer cosmic dusk, and for the first time the universe feels less like an explosion and more like an organism, alive, stretching, learning what it can become. You drift near one of the earliest proto-galaxies, a clumpy, chaotic cloud of stars and gas. It's far smaller than the galaxies you know, maybe 1,000th the mass of the Milky Way, but its ambition is infinite. It spins lazily, tugging new material inward, feeding on smaller neighbours that wander too close. This is how galaxies begin, not with grandeur, but with hunger. Inside, the stars form in bursts. Some regions glow with newborn light, others are still dark, thick with unignited hydrogen. Gravity does its slow, tireless work, pulling and compacting while radiation pushes outward, trying to escape. You can sense the tension between them, the quiet tug of war that defines all cosmic growth. Each region of this proto-galaxy is its own experiment, some stable, some collapsing, some exploding spectacularly. The chaos is total, yet within it, something like balance begins to take root. Historians still argue whether the first galaxies formed bottom-up, small clumps merging into larger structures, or top-down, collapsing from immense gas clouds all at once. The current consensus leans toward the former, the slow assembly of the many into the few. But here, floating in the early universe, you realise that both could be true. Some regions collapse fast and furious, while others gather quietly over eons. Nature never chooses just one recipe when it can try them all. As you drift closer, you see bright filaments of gas connecting this proto-galaxy to others nearby. These filaments aren't decorative, they're rivers, feeding galaxies with a steady stream of raw hydrogen and helium. They glow faintly under the ultraviolet light of nearby stars, forming a network that stretches across light years. It's as if the universe has discovered vascular structure, arteries of creation pulsing with matter. You can almost imagine it breathing, a quirky tidbit for your drifting mind. Some astrophysicists affectionately call this stage cosmic adolescence. The universe is still messy, moody, and prone to overreacting, but it's starting to show structure and self-awareness. It's the galactic equivalent of a teenager figuring out how to stand up straight. You'd almost expect it to roll its eyes at you and mutter something about space-time being unfair. Deep within the proto-galaxy, new generations of stars are forming from the remnants of their ancestors. The gas here is richer now, seeded with elements heavier than helium. These metals cool the clouds more efficiently, allowing smaller, longer-lived stars to form. Many of them will shine for billions of years, patient beacons that will still burn when most others fade. You hover near one of these forming clusters, watching stars ignite like slow fireworks. Around them, disks of dust begin to swirl, the earliest hints of planetary systems, though real planets won't appear for hundreds of millions of years yet. Historians still debate what those first planetary seeds might have looked like. Some suggest rocky fragments formed even in these early days, tiny worlds of iron and carbon orbiting short-lived stars. Others argue that the universe was still too raw, too hot for stable planets to coalesce. Whichever is true, you can see the ingredients gathering: metals, silicates, carbon dust, all the necessary chemistry quietly waiting for its cue. You move through the outskirts of the proto-galaxy, where gravity's hold weakens and the light grows thin. Here, streams of gas stretch outward, caught between competing gravitational pulls. Some of it will drift away forever, becoming part of the vast intergalactic medium. Some will fall back like a tide turning inward, to feed new waves of star formation. You can feel the rhythm of it, the universe's earliest inhale and exhale. It's not random anymore. It's alive with purpose, even if that purpose is still wordless. Now and then, two proto-galaxies drift too close and their mutual gravity locks them in a slow, spiraling embrace. You watch one of these meetings unfold over millions of years. At first, the galaxies pass through each other, like ghosts, their stars barely colliding. But their gas clouds crash spectacularly, compressing and igniting in bursts of new light. Each pass draws them closer until they merge, forming a larger, brighter system. You might call it cosmic romance, except it ends with the destruction of both parents. Still, out of that violence comes something grander, a new galaxy, stronger and more luminous than either alone. A fun little note from modern astronomy. This process never really stops. Even now, in your own Milky Way, tiny satellite galaxies continue to merge with us, their stars stretched into long, faint streams across the night sky. You've seen them before, even if you didn't know what you were looking at. The faint traces of the Sagittarius dwarf galaxy, for example, arcing across our halo. The universe doesn't waste a good merger. It just keeps building upward, generation after generation. You linger for a moment, watching as the newborn galaxy settles into something almost familiar. A spinning disk, a bulging core, tendrils of starlight curling outward. It's still rough around the edges, but the pattern is unmistakable. This is the template for all that will follow, the foundation of every future night sky. The cosmic darkness beyond it still stretches endlessly, but the emptiness feels different now. You can see light travelling across space, faint beams connecting one galaxy to another. Each pulse of radiation a message from the past. The silence hums with activity, with structure. The universe is no longer simply expanding, it's organising. You realise, drifting there, that you're watching the first true communities of matter forming. These galaxies are not isolated. They're bound together by filaments of dark matter, drawn into vast networks that will one day shape the cosmic web. Each galaxy is a cell in an organism far beyond your comprehension. And though it's still young, still fragile, it's learning how to be beautiful. You drift through a universe that has discovered its appetite. The galaxies are young, restless, and starved for new material. Everywhere you look, clouds of hydrogen swirl and collapse, glowing faintly under the ultraviolet light of the newborn stars within them. The great cosmic kitchens are open for business. Supernovae from the first generations have enriched the interstellar gas with heavy elements. Iron, carbon, oxygen, all the ingredients for new recipes of creation. You can almost smell it if space had smells. Scorched plasma and the faint ozone tang of ionized light. The universe is cooking, and it's cooking fast. You pass through a nebula the size of a small galaxy, its colours invisible to human eyes but radiant in the ultraviolet. In this place, gas and dust form thick, undulating curtains. Inside those veils, gravity kneads the material into denser pockets where stars will soon ignite. It's a cosmic bake-off. Heat, pressure, and patience combining to make something bright. A fun tidbit, and scientists sometimes call these regions stellar nurseries, but that makes them sound too gentle. They're more like forges roaring with energy, sculpting light itself into structure. The early galaxies are chaotic kitchens, each experimenting with its own flavour of star formation. Some form stars steadily, others in wild bursts. You hover near one that's overachieving. Every few million years, a new wave of stars ignites, turning entire regions blue-white with radiation. The starlight pushes against the surrounding gas, creating enormous bubbles where the pressure grows until, pop, new clusters are born. It's both mesmerizing and exhausting, the universe discovering rhythm through explosion. Historians still argue whether this phase marked the true peak of star formation or merely a rehearsal for the grandeur to come. Some simulations suggest that starburst galaxies, those wild, overproductive systems, dominated the early epochs, while others insist that quieter, more methodical galaxies did the heavy lifting. Floating here, you suspect both are right. Creation rarely sticks to one pace. It prefers the full symphony, loud and soft, fast and slow. Supernovae ripple through these galaxies like fireworks, enriching the gas with metals that cool the surrounding clouds faster, helping new stars form more easily. You glide past the shockwave of one such explosion. Its light outshines everything nearby, its energy reshaping the entire region. The dying star's debris expands into intricate filaments, glowing with the spectral fingerprints of every element it created. You recognize them like old friends: carbon, calcium, iron, the periodic table scattering itself across space. Someday these atoms will drift far enough to join new worlds, new skies, maybe even new thoughts. A curious debate continues among modern astronomers. How far did those heavy elements travel in the young universe? Some think they stayed close, locked within their host galaxies. Others believe they escaped into intergalactic space, carried by powerful winds from supernovae and quasars. You can see hints of both as you drift, the faint traces of metal-rich gas spreading outward, and denser pockets where the material sinks back in, recycled again and again. The cosmos is messy, but it never wastes. As you glide toward the outskirts of a growing galaxy, you notice that not all light here is steady. Some of it flickers with unnatural intensity. Quasars, those luminous beacons powered by feeding black holes. Each one is a cosmic furnace devouring gas and radiating energy across unimaginable distances. If stars are candles, quasars are blowtorches cutting through the dark with reckless power. You watch one spin up, its accretion disk blazing as matter spirals inward at near light speed. The jets shoot out perpendicular to the disk, bright spears of plasma stretching thousands of light years. They pierce the surrounding space, lighting up everything in their path. A quirky tidbit for your curiosity: quasars are so bright that astronomers once mistook them for stars within our own galaxy. The name comes from quasi-stellar radio source. It wasn't until decades later that they realized these objects lived billions of light years away, powered by supermassive black holes at the centers of ancient galaxies. You can almost imagine the cosmic embarrassment, thinking you'd found a bright neighbor, only to discover it was a city burning on the other side of the universe. You watch as the quasar's radiation sculpts its environment, blowing away nearby gas and halting star formation in its host galaxy. It's a self-regulating system. Feed too fast and you starve your surroundings. It's oddly poetic, creation and destruction perfectly balanced, like the universe learning restraint through its own excesses. Historians still debate whether quasars helped or hindered galactic growth. Some models show them as architects, clearing out old gas so that galaxies could evolve in cleaner, more stable shapes. Others argue they were bullies, quenching potential star formation before it had a chance to flourish. Floating near one now, you realize the truth might depend on timing. Too early and they destroy, too late and they illuminate. The universe, like every artist, struggles with pacing. You drift away, leaving behind that fierce brightness, and find yourself among quieter galaxies, smaller, dimmer, but steadier. They hum with gentle radiation, their stars arranged in primitive spirals and ellipses. These are the builders, the quiet ones, forming the foundation of cosmic architecture. Their disks are full of dust, swirling with slow confidence. You feel at peace here, as though the universe has finally learned how to breathe evenly. The light of billions of stars flickers across your path as you pass between them. You think of all the cycles at play: birth, death, collapse, renewal, and realize this is not chaos, but choreography. The universe has a rhythm now. The raw fire of the beginning has cooled into balance, and galaxies are becoming more than experiments. They're becoming homes. As you drift onward, the silence deepens. It's not empty anymore. It's full of the echo of energy well spent. You look back at the glowing galaxies receding behind you and feel an almost human sense of awe. The cosmic kitchen has quieted, the oven still warm. What began as a scattered mist has become a tapestry of light, woven by gravity's invisible hand and stitched together with time. The great bake-off of stars may be slowing, but its scent, the faint glow of hydrogen and helium, still lingers through the endless dark. You linger in the gentle afterglow of the universe's first real masterpieces, the galaxies that now spin and shimmer like jeweled pinwheels. Yet amid their beauty lies something darker, literally. At the centers of many of these galaxies, black holes are quietly, or not so quietly, feeding. You drift toward one now, drawn by curiosity and the faint, trembling light that surrounds it. The region is neither bright nor dark, but a paradox of both. Gas swirls in vast spirals, glowing hotter the closer it falls. Radiation crackles, magnetic fields twist like ropes of lightning, and then, suddenly, everything disappears into nothing. You hover near the event horizon, that invisible border, where space folds so tightly that time itself forgets what to do. The black hole doesn't roar or scream. It hums, a deep, inhuman frequency that seems to vibrate through your bones. If you could hear it, it would sound like the baseline of existence, a note held for billions of years. Around you, matter races inward, forming a bright accretion disk hotter than 1,000,000 suns. Some of that matter escapes along magnetic jets. shooting out perpendicular to the disk at nearly the speed of light. The jets blaze for thousands of light years, carving luminous scars into space. Historians still argue whether black holes created galaxies or if galaxies birthed black holes. It's the great cosmic puzzle, an argument that has filled countless observatories and conference halls, or as astronomers point out that the mass of a galaxy's central black hole is directly proportional to the mass of its bulge, as if the two grew up together, inseparable. Others suggest that black holes were latecomers, opportunists feeding on the chaos that galaxies left behind. Floating here, watching the interplay of gravity and light, you get the feeling they're co-conspirators, neither truly leading nor following. There's something almost sentimental about the way the surrounding gas moves, like water spiralling down a drain, each molecule tracing a perfect path to oblivion. You notice with quiet amusement that even destruction can be elegant. And while this black hole consumes matter, it also creates order, regulating star formation by heating the surrounding gas, shaping the flow of galaxies across millions of light years. This is no mindless void, it's a cosmic manager, trimming excess and sculpting the balance of creation. A quirky tidbit, physicists have theorized that black holes might not be holes at all, but holographic prisons for information. Every atom, every photon that falls in might leave an imprint, encoded somehow on the event horizon's surface. It's called the holographic principle, a mathematical whisper suggesting that the universe itself could be a projection of something deeper, flatter, stranger. You glance at the swirling edge of the black hole and can't help but imagine it as a cosmic hard drive, quietly storing the memories of everything it devours. Far from the black hole, stars continue to form in the surrounding galaxy, almost indifferent to the monster at their center. The spiral arms glow with dust and gas, their motion graceful and steady. You drift through one of these arms, past clusters of brilliant young stars surrounded by pink nebula. The light filters through the hydrogen clouds like sunrise through fog. You can feel warmth again, gentle and familiar after the cold indifference of the void. The contrast between the calm and the chaos is staggering. The same galaxy holds both serenity and catastrophe side by side. Historians still debate what conditions allow such balance to exist. Some galaxies are torn apart by their central black holes, their gas stripped away by radiation and jets. Others thrive, forming stars steadily for billions of years despite the gravitational monster in their core. Perhaps it's luck, perhaps it's the slow feedback of cosmic trial and error. Whatever the reason, this galaxy hums in equilibrium, a rare harmony between light and dark. You notice faint arcs of stars looping far above and below the disk, remnants of old collisions, the fossilized trails of smaller galaxies devoured long ago. They shimmer like ghostly ribbons, reminders that even stability is built on violence. In one of those arcs, a few ancient stars flicker weakly, their light stretched red by the passage of time. Some of them are as old as the universe itself, survivors from the very first generation. Their cores are made of pure helium, slowly cooling, fading into the quiet. A curious thought slips through your drifting mind. Black holes, despite their reputation, are also midwives of renewal. When they feed, they blast energy outward, stirring the gas in their galaxies and triggering new waves of star formation. In a sense, they're cosmic chefs stirring the pot to keep the flavors from settling. You almost laugh at the thought, a black hole with a spatula, flipping galaxies like pancakes. But there's truth in it. Without those violent outbursts, the universe might stagnate. Even destruction has purpose here. As you drift away from the central region, the galaxy's hum softens into a low glow. You look back once more at the black hole, now just a dark dot surrounded by faint light, and realize it's not a villain in this story. It's a keeper of rhythm. Every galaxy you've seen has one like it. Massive, ancient, patent. They've been here since the dawn, quietly ensuring the balance between order and chaos. You move on through the intergalactic medium, the space between galaxies thick with whispers of radiation and thin streams of gas. The filaments of dark matter still weave their invisible web, binding everything together. You can feel the faint pull of gravity tugging you toward the next node of light, another galaxy forming at the intersection of unseen threads. Everywhere, black holes are being born, each one an echo of the same quiet design. The universe, it seems, loves symmetry. Every creation has a counterpoint, every star a shadow, every light its gravity. As you drift, you realize the quiet birth of galaxies was never just about light appearing in darkness. It was about the darkness learning to sculpt the light. The galaxies, the stars, the black holes, they're all part of one vast breathing organism that's still learning how to exist. You glide onward into the slow dance of colliding galaxies ahead. Behind you, the black holes hum like heartbeats, steady and eternal. You feel the universe stretch around you like a canvas painted with motion. Ahead, two galaxies approach each other in a slow, magnificent collision. Though calling it a collision feels wrong. Nothing smashes or shatters here. It's more like two vast, luminous ghosts passing through one another. Their stars rarely touching, but their gravity locking in a long, irresistible embrace. You drift closer, watching the delicate choreography unfold over millions of years. Tidal forces pull out long streams of stars and gas, curling them into elegant tails that arc across hundreds of thousands of light years. It's breathtaking, like watching two dancers spin so close that the air between them catches fire. At first, the galaxies seem to resist, pulling apart again, but gravity is patient. It calls them back together, again and again, until they merge completely. You hover between them as their spiral arms stretch and twist, forming loops and bridges. Entire constellations are flung into space like sparks from a forge. Within the chaos, clouds of gas compress, triggering wild bursts of new star formation. This is the most brilliant stage of galactic evolution, the age of starbursts, when galaxies burn with the intensity of their own transformation. Historians still argue whether most of the galaxies we see today are products of such mergers, or if some grew quietly, avoiding the cosmic traffic. Evidence suggests that the grandest structures, elliptical galaxies, the massive glowing cities of stars, were born from collisions like this. Spirals, by contrast, may have survived longer without too many violent encounters. You can almost sense the personalities forming. Some galaxies calm and orderly, others dramatic and tempestuous. You float near the core of the merging pair. The centers of both galaxies, each harboring a supermassive black hole, are drawing closer. The two invisible titans orbit each other in tightening circles, dragging space-time along with them. The surrounding stars sway to the rhythm, their orbits disrupted, many flung into the galactic halo, or ejected entirely into the intergalactic dark. The energy here is staggering. If sound could travel through this vacuum, it would thunder. A quirky tidbit: when two black holes like these finally collide, they don't do so quietly. They send ripples through the fabric of space-time itself, gravitational waves like the deep bass of the cosmos rolling across eternity. Billions of years later, on a small blue planet orbiting a middling star, instruments made of gold and lasers will detect those faint vibrations, confirming Einstein's century-old prediction. You'll hear about it in the news, probably over morning coffee, and for a brief moment, the echo of this cosmic waltz will touch your life. The merging galaxies glow brighter than ever now. Starburst regions erupt like fireworks, their light so intense it outshines everything else for millions of light years. Yet the beauty is temporary. The gas that fuels these fireworks will soon run out, consumed or expelled by fierce stellar winds and supernovae. The combined galaxy will age rapidly, settling into a quieter, rounder form, a giant elliptical full of old red stars burning low. What began as a spiral of chaos will end as a serene golden glow. Historians still debate what happens to the stars thrown into the darkness during these collisions. Some drift forever between galaxies, forming vast populations of homeless stars that light the intergalactic medium with a faint, diffuse glow. Others fall back over eons, pulled by gravity into the new, larger galaxy. You drift among some of these exiles, their pale light flickering in solitude. They're lonely but free, eternal wanderers in the spaces between. Amid the turbulence, you find small clusters of new stars, blue and fierce, born from the shock of the merger. Around them, dusty disks begin to swirl. The first planets of this new galaxy will someday form here, inheriting the metals forged in the chaos. Every atom in those planets will carry the memory of collision. The hydrogen from ancient stars, the oxygen from supernovae, the iron from the cores of giants. The universe doesn't erase its past, it repurposes it. As the merger slows, gravity settles into new patterns. The distorted spiral arms fade. replaced by a vast oval of stars orbiting a shared center. The twin black holes have now merged into one, more massive and even quieter. You can feel its gravitational field extend for light years, a calm after the storm. The surrounding stars move in smooth elliptical paths, their orbits synchronized by the silent authority of their central void. A curious fact, some simulations suggest that when galaxies merge, their central black holes can recoil after collision, literally being kicked out by the asymmetric emission of gravitational waves. Somewhere in the distant dark there may be black holes flying through intergalactic space, homeless kings without kingdoms. You glance into the void, half expecting to see one racing past, a dark bullet moving silently forever. You drift to the outer edges of the newborn elliptical galaxy. The chaos has subsided, replaced by an almost holy calm. Thousands of ancient suns glow faintly red, their light blending into a golden haze. There's no more dust, no more wild bursts of star formation, just a slow, peaceful radiance. The galaxy has matured, burned through its youth, and found equilibrium. Historians still debate whether this aging is truly an end or just another phase. Some believe ellipticals are the final stage of galactic evolution, destined only to fade. Others think new infusions of gas, perhaps from future collisions, might reignite them. Watching from this vantage, you suspect the truth is both simple and profound. Nothing in the universe ever truly ends. It only changes tempo. You drift farther out, watching the faint tendrils of starlight fade into the black. In the quiet beyond, new galaxies are still forming, others still colliding. The dance continues everywhere, infinite and slow. You smile to yourself, or at least you think you do. The cosmos doesn't rush, it never did. Creation here isn't an explosion, it's waltz, and gravity is the only music that never stops playing. You glide through a sea of galaxies now mature enough to recognize themselves in the broad mirror of light. The collisions that once dominated the cosmos are less frequent, though their fingerprints remain. Tidal streams, warped disks, and faint trails of orphaned stars stretching across intergalactic space. The universe has settled into something resembling order, though its heart still beats with quiet urgency. You drift toward one spiral galaxy, luminous and poised, its arms unfurling gracefully like ribbons of silk. It spins with such perfect balance that you could mistake it for peace, but beneath that beauty, chaos still simmers. You move closer, passing through its outer halo. The stars here are ancient, dim and red, drifting in near solitude. They orbit slowly, tracing vast ellipses around the galactic core. Their light feels tired, as if they've seen too much of time. This halo is a fossil, a living museum of the galaxy's past. Its earliest generations of stars, the remnants of cannibalized dwarfs, and the invisible threads of dark matter that hold it all together. The pull of gravity is faint but constant, like the low hum of a heartbeat you can only feel, never hear. As you drift inward, the spiral arms reveal themselves more clearly. Each one is a tapestry of motion, clusters of young hot stars glowing blue-white veiled by dustiness that turns their light to gold. Between the arms lie dark lanes of molecular gas, cold and fertile, the cradles of new suns. You move through one, and the view is hypnotic. Dense clouds swirl, collapsing slowly under gravity's patient insistence. Inside, pockets of gas ignite, and you watch a star come to life, its core flickering, its pressure balancing perfectly against its own collapse. It's the same quiet miracle that's been repeating for billions of years, and still, somehow, it feels personal. Historians still argue why spiral galaxies form those elegant arms at all. Are they fixed structures, or merely waves of density moving through the galactic disk, like ripples on a pond? The debate began in the 20th century and hasn't truly ended. Some models treat the arms as patterns of traffic, stars and gas bunching up then dispersing, a gravitational slow jam that looks like solid form but isn't. Floating here, you can see the truth for yourself. The arms aren't objects, they're a choreography. Every star here plays its part in a dance that repeats endlessly, always changing, always the same. A quirky tidbit floats into your thoughts. The Milky Way's own spiral arms were once mapped using nothing more than radio signals from hydrogen gas. In the 1950s, astronomers tuned into the 21 centimetre line, a whisper emitted when hydrogen atoms flip their electron spins. That faint radio note, imperceptible to human ears, revealed the structure of our home galaxy long before we could ever see it. It's oddly poetic that we first learned our place in the cosmos not by looking up, but by listening carefully. Deeper inside the galaxy, the arms narrow toward a bright central bulge. You drift closer, through a field of aging stars packed so tightly that their light merges into a golden glow. The air here, if you could call it that, is thick with radiation. At the very centre lies the heart of the galaxy, a supermassive black hole, calm and luminous with the light of falling matter. You sense it, but this time there's no violence, no chaos. The hole sleeps, content, its appetite sated for now. Around it, stars orbit in near-perfect harmony, tracing the geometry of invisible gravity. Historians still debate whether these bulges form through the slow accumulation of stars or the merger of smaller galaxies. Some argue that central bars, those bright linear structures cutting across many spirals, act as cosmic conveyor belts, funneling gas toward the centre to build the bulge. Others believe they're scars from long-ago collisions. Watching from this quiet vantage, you see both processes at work. The universe, as usual, refuses to pick a favourite. You glide outward again beyond the luminous heart and pause above the spiral arms as the galaxy turns beneath you. Its rotation is slow but mesmerising, hundreds of millions of years for a single revolution. Yet there's a mystery hidden in that graceful spin. The outer stars move faster than they should. According to Newton's old equation, Citius, the galaxy ought to fly apart, but it doesn't. Something unseen holds it together. A curious fact, it was this very observation in the 1970s that led astronomers like Vera Rubin to confirm the existence of dark matter. The star's motions made no sense without it. You glance through the galaxy's halo again, knowing that most of its mass lies not in the glittering disk, but in invisible matter stretching far beyond what you can see. It's strange, isn't it? The beauty of galaxies comes from the light, but their shape, their strength, their endurance, it all belongs to the dark. You drift beyond the spiral arms now, into the thin edge where starlight fades. From here, the galaxy looks like a shining coin suspended in darkness, its arms faintly glowing, its halo shimmering with an unseen power. Beyond it, other galaxies scatter like distant lanterns across an infinite black sea. Some are edge-on slivers, others are round and fuzzy, glowing with the quiet persistence of time. Each one a story, a family of stars, a home for something yet unimagined. Historians still argue about how long the universe can sustain this harmony. Star formation is slowing everywhere. The gas supply is dwindling, the lights beginning to dim, even if only slightly. You can feel it, an almost imperceptible cooling, a shift from frenzy to calm. The universe isn't dying, not yet. It's maturing. The cosmic dance has found its rhythm, and you, still adrift in its music, realize you're witnessing the middle movement of a symphony that began with silence and will end with it too. You linger for a while longer, gazing across the endless field of spirals and ellipses, each one a variation on the same song. The quiet birth of galaxies isn't over. It's simply slowed into grace. The universe is still creating, still spinning, still whispering, and you, tiny and timeless, are here to listen. You continue drifting through the cosmic web, and the light around you begins to sharpen. The universe is entering a new chapter, one where clarity reigns and light finally moves unhindered across unimaginable distances. For hundreds of millions of years, much of space was shrouded in a cosmic fog, a haze of neutral hydrogen that absorbed and scattered starlight. But now, the fog is lifting. The age of reionization has begun, and for the first time since the Big Bang, the universe is truly transparent. You hover in awe as entire regions of space brighten, as if dawn is sweeping through eternity itself. It happens slowly, almost imperceptibly, like frost melting from glass. The ultraviolet light from countless young stars and quasars strikes the hydrogen atoms, filling the intergalactic medium, stripping away their electrons and turning them into plasma. The darkness recedes, not in a single burst, but in expanding pockets of light. Each galaxy becomes a beacon, clearing its own bubble of visibility. Those bubbles grow, merge, and finally connect, transforming the universe into a single vast ocean of light you can see forever now, well, almost forever. Historians still argue about the exact timeline of ionization. Some say it began around 400 million years after the Big Bang and took a few hundred million more to complete. Others suggest it happened more unevenly, with certain regions brightening much earlier than others. The James Webb Space Telescope, your ever-patient time machine, peers deep into that era, trying to catch the universe mid-change. Its golden mirrors collect light so ancient that you can almost feel the photons sigh with relief at finally finding a place to land. You drift among these newly clear skies, tracing the outlines of galaxies you couldn't have seen before. They're young, clumpy, and wildly energetic, like toddlers with too much sugar. Starburst regions flare everywhere, and the light spills out freely now, unfiltered by cosmic haze. For the first time, radiation travels vast distances without being trapped. It's as if the universe took its first deep breath and decided never to hold it again. A quirky tidbit to amuse you. Astronomers sometimes describe this process as the universe turning the lights back on. The phrasing makes it sound like someone just found the switch behind the fridge of creation. And honestly, that's not far off. The fog lifting marks a profound transformation, not just in visibility, but in chemistry, structure, and destiny. The transparency of space allows gravity to act across larger scales, guiding the assembly of galaxies, clusters, and the grand architecture of the cosmic web. You pass through a filament of newly ionized gas stretching between galaxies. It glows faintly blue, charged particles dancing like fireflies in ultraviolet starlight. These filaments, invisible to most eyes, are the highways of the cosmos, channeling matter toward the dense intersections where galaxies thrive. They pulse gently, carrying whispers of temperature fluctuations, echoes of the very first ripples in the cosmic microwave background. You can almost sense the universe remembering its infancy as it moves forward into clarity. Historians still debate which sources of light were the main architects of reionization. Were the first galaxies with their swarms of hot young stars enough to clear the fog? Or did quasars, those ravenous black hole furnaces, do the heavy lifting? The evidence wavers, like heat above a desert road. Some models suggest a partnership between the two, galaxies starting the process, quasars finishing it. Floating here, surrounded by both, you see how the balance feels right. The universe rarely trusts a single hand with anything important. You glide toward one of the brighter galaxies in this reionizing sea. Its light is fierce, almost too much to bear. The core glows with the quasar's relentless hunger, while the outer regions shimmer with newborn stars. The radiation pouring from it slices through the surrounding hydrogen like sunlight through fog, creating a clear sphere dozens of thousands of light-years wide. From your vantage, it looks like a cosmic lantern floating in an ocean of mist. You could almost mistake it for loneliness, but it's not. It's freedom. A fun detail that astronomers love, the light from these early galaxies has been stretched, redshifted, by the expansion of space itself. What once blazed in ultraviolet now reaches modern telescopes as soft infrared. That's why the James Webb was built to see in heat instead of visible light. Every photon it captures carries the memory of distance and time, stretched thin by 13 billion years of cosmic breathing. You're looking at galaxies both ancient and newborn, their light arriving just now after a journey older than Earth itself. You drift beyond the luminous bubbles into a region still cloaked in haze. The difference is startling here. Light scatters and fades again, muted by clouds of neutral gas. It's a reminder that the universe's transformation was patchy and uneven, like the last embers of fog before sunrise. Pockets of darkness still linger for millions of years, stubborn and cold, until more light finally seeps in and clears them away. Historians still argue whether reionization ever truly ended. Technically, yes, space became mostly transparent. But even now, billions of years later, traces of neutral hydrogen persist in the cosmic web, absorbing and releasing radiation in quiet conversation. The process wasn't an event, but a transition, one that gave the universe a face it could finally recognize. You emerge once more into clarity. Around you, galaxies glow freely in the open dark, connected by silver threads of plasma and dust. Light travels unhindered from one corner of space to another, weaving together an ever-expanding network of visibility. You realize you're witnessing the universe's great unveiling, the moment when existence went from hidden to seen, from murmur to music, and as you float there, surrounded by galaxies blazing in the first true transparency, you can almost hear the soft applause of creation finishing its overture. The fog has lifted, the lights are on, and the stage of eternity is ready for whatever story comes next. You drift forward into a calmer epoch, where the universe finally begins to feel settled. The chaos of reionization has faded into equilibrium. Galaxies have matured into steady luminous forms, spirals glowing with organized grace, ellipticals humming softly with old red light. The vast cosmic web stretches clear and visible now, filaments of dark matter and gas linking every glowing island across hundreds of millions of light years. The expansion of space continues, silent and tireless, but within those threads, gravity holds the galaxies close enough to form something new, structure with permanence. You can almost sense the sigh of relief in the fabric of existence, like a builder stepping back to admire a finished foundation. You pass through a cluster of galaxies that shine like lanterns in a deep still pool. Each one has its own character, some blue with youth and star formation, others golden with the glow of old age. Between them lies a diffuse mist of hot gas, thin as smoke yet vast enough to outweigh all the stars combined. This is the intracluster medium, a sea of plasma heated to tens of millions of degrees by gravity's slow compression. You can feel its faint warmth ripple through space, the aftertaste of ancient violence now settled into calm. Historians still argue exactly when this cosmic noon occurred, this period when star formation across the universe reached its peak before beginning its long decline. Most agree it happened roughly 3 to 4 billion years after the Big Bang, long before Earth, long before thought, but the traces of it still echo in the spectra of distant galaxies. You look around, and yes, it feels like high noon in eternity. Light floods everything. The universe hums with confidence. You glide toward a single spiral galaxy within this cluster. Its arms sparkle with new stars, while its nucleus glows softly from a resting black hole. Around it, smaller dwarf galaxies orbit like moons, some being slowly torn apart by tides of gravity. Streams of stars stretch between them, luminous bridges of motion. The great cosmic suburbs have arrived. Where once galaxies lived alone, now they gather in neighborhoods, forming groups and clusters that will eventually bind into superclusters. The universe is becoming social. A quirky tidbit. Astronomers once nicknamed our own region of the cosmos the local group, as if the Milky Way, Andromeda, and a few dozen dwarfs were members of a quiet intergalactic book club. The names are endearingly bureaucratic for something so enormous. Yet it's fitting. This is the age when galaxies form communities, when gravity's invisible handshake links them into shared futures. You pass beyond the central spiral into the intracluster space again. Here, faint X-rays flicker from hot gas, tracing the boundaries of gravitational wells. Somewhere in that glow, galaxies occasionally collide, their stars passing through one another while their gas clouds ignite in brief bright storms. Most, however, simply orbit in peace, bound by a collective centre of mass like planets around a distant sun. You can feel the serenity settling in. The universe is still dynamic, but the tempo has slowed. Historians still debate why star formation begins to taper during this time. Some point to the dwindling gas supply, so much material locked into stars that little remains to fuel new generations. Others blame feedback from black holes and supernovae, their outbursts heating and expelling the cold gas that stars need to form. It's probably both, working in uneasy alliance. Whatever the cause, the effect is clear. The cosmos is shifting from creation to maintenance. The great construction phase is ending. You drift through the spiral arms of another galaxy and notice the stars here move with a quiet grace absent in earlier epochs. The light is softer now, the colours richer. Dust glows in infrared, radiating the warmth of starlight absorbed and re-emitted over centuries. If you could breathe here, it would smell of warm iron and faint ozone, a universe in gentle middle age. Somewhere within one of these arms, you see a small yellow star forming planets. It's unremarkable in this sea of light, yet its significance ripples forward in time. You feel a strange premonition, though you can't quite name it. A fun fact: during this epoch, galaxies begin to exhibit the famous Hubble sequence, that tidy classification astronomers use even today. Spirals, ellipticals, irregulars, all catalogued like birds in a field guide. It's almost comforting how human minds, billions of years later, will impose order on this cosmic garden, labelling shapes that were once pure improvisation. You drift above one of these grand spirals and realise it fits neatly into that future taxonomy. A luminous example of cosmic order achieved. Far beyond, the cluster stretches into filaments that connect with others, forming walls and nodes of galaxies spanning hundreds of millions of light years. These are the cosmic superclusters, the largest coherent structures in existence. You trace one filament with your gaze, watching it weave across the dark like a thread of glass. The spaces between them, the cosmic voids, are immense and eerily empty. You pass through one for a moment, and the silence there feels absolute, a reminder that even at its busiest, the universe leaves room for nothingness. Historians still debate whether the cosmic web is a static sculpture or a living organism. Does it grow and shift as matter continues to flow along its strands, or is it already frozen by expansion, its shape preserved forever? Floating here, it feels alive. The filaments pulse faintly with radiation, as though gravity itself were still breathing through them. You can almost feel the heartbeat of the cosmos beneath your feet, or whatever counts as feet when you're a wandering consciousness in space. You drift back toward the bright core of the cluster and glance across its galaxies, all spinning in their quiet harmony. There's comfort in the predictability of it, in the way everything finally seems to know what it's doing. The universe has found its stride. For the first time, light travels freely. Stars burn steadily, and galaxies live long, peaceful lives. It's a golden age, a long afternoon before the shadows of entropy begin to stretch across the cosmic floor. And as you watch it unfold, you realize something simple yet profound. This stillness isn't the end of creation, it's the pause between breaths. The universe, ever patient, is resting only so it can dream again. You move through the golden calm of a universe grown confident in its structure. Galaxies hum in their clusters, content to orbit and evolve. The great webs of matter stretch so far that perspective itself seems to fail, no up, no down, only connection. You pass into one of these immense junctions where hundreds of galaxies gather, a glowing metropolis suspended in infinite darkness. The light here is thicker, more intricate. Every gleam, every ripple of X-rays tells of gravity's slow architecture. Galaxies drawn together, compressed and heated, until they shine not only from stars, but from the very friction of existence. From a distance, a galaxy cluster looks like a single shimmering pearl. Up close, it's chaos disguised as elegance. Galaxies weave past one another in slow motion, bound by mutual gravity but rarely colliding head-on. Between them lies an ocean of hot plasma, rich in iron and silicon dust. You drift through that invisible sea, feeling faint vibrations, shocks from supernovae, and the tidal murmurs of passing giants. It's not empty here, though it looks it. Even the darkness glows faintly in microwaves, the residual warmth of a universe still cooling from its birth. Historians still argue how these colossal clusters assembled so early. Some simulations insist that small groups of galaxies merged gradually, century by cosmic century, until the clusters reach their massive scale. Others suggest the web itself, those invisible filaments of dark matter, guided gas and stars directly into these dense nodes. Standing here, you can almost watch both stories unfolding at once, tiny galaxies sliding together along gravitational strands, while dark matter shapes the stage beneath them. You drift past a titanic elliptical galaxy near the cluster's core. It's a lumbering monarch, thousands of times the mass of the Milky Way, glowing amber with the light of trillions of old stars. No gas remains to birth new suns. Every element is locked into orbits of quiet age. The starlight here feels ancient, patient, wise. Around it swarm smaller galaxies, like satellites caught in the pull of an empire. The central black hole at its heart is monstrous, billions of solar masses, and yet it sleeps, radiating momentum jets as if sighing in its dreams. A quirky tidbit slips through your drifting mind. Some clusters emit what astronomers poetically call radio halos. These faint glows are caused by electrons spiraling through magnetic fields, producing radio waves that envelop the entire cluster. It's as if the galaxies share one vast, invisible aura, a cosmic whisper audible only to antennas. Floating here, you can sense that whisper, low and soothing, the combined hum of gravity and time. Farther out, you encounter a collision between two clusters, a rare but spectacular sight. The galaxies themselves mostly pass through unharmed, but their clouds of plasma crash together in colossal shocks that span millions of light years. The temperature spikes to tens of millions of degrees. X-rays pour out in sheets of brilliance. If you could listen, it would sound like thunder stretched across centuries. One such collision, recorded from Earth billions of years later, will be nicknamed the Bullet Cluster. It will provide one of the best pieces of evidence for dark matter, showing how the invisible mass separates from ordinary gas during impact. Historians still debate the exact dynamics of that event, but the cosmic message is clear. What you can't see often outweighs what you can. You linger on the outskirts, where galaxies are still trickling into the cluster's gravity well. Some come willingly, others tumble in by accident. Their paths warped by the invisible threads connecting everything. You watch one small spiral fall inward, its arms distorting as tidal forces stretch it thin. Gas is stripped away, leaving behind only its core, a dim spheroid that will join the ranks of the old and red. The cluster is both cradle and grave, welcoming newcomers while erasing their individuality. Historians still debate whether these dense environments nurture or stifle galactic life. Some data suggest clusters quench star formation, starving galaxies of gas. Others hint at brief bursts of creation triggered by gravitational harassment. From where you float, the truth looks complicated as always. Some galaxies fade quietly, others flare in defiance before dimming. The cluster isn't cruel, it's impartial. Gravity doesn't judge, it only gathers. You move outward along one of the connecting filaments. The further you travel, the thinner the light becomes. Galaxies stretch into long chains, each one tugged by its neighbours. Between them lies mostly nothing, hydrogen atoms scattered across light years. The faint echo of cosmic microwave background still humming behind it all. You realise these filaments are the true skeleton of the cosmos, holding everything together in ways invisible to most eyes. Even now, matter fuse along them in slow rivers, feeding clusters like veins feeding a heart. A fun note from modern astronomy: the largest structure ever mapped, the Hercules Corona Borealis Great Wall, spans more than 10 billion light-years. It's so vast that light from one end hasn't yet had time to reach the other since the universe began. Floating here, you can feel its scale pressing softly against your awareness, a reminder that even the word large becomes meaningless out here. You pause amid the silence, watching galaxies twinkle like distant campfires scattered across the web. Somewhere, perhaps halfway across the observable universe, other clusters mirror this one, grand gatherings of matter caught in the same slow dance. You think about the symmetry of it, the balance between void and fullness. It feels intentional, though logic says it's not. The universe is simply efficient. It fills the spaces where gravity can work and leaves the rest for mystery. As you drift farther from the core, the light dims until only faint glows remain. You realize you're seeing the universe at its busiest and most beautiful, yet also at the beginning of its long decline. Star formation is already slowing, the grand clusters are tightening their grips. The universe has found its shape, and in doing so, it has sealed its fate. You smile into the dark, sensing that even perfection carries the seed of ending. You drift through a universe that has become stately in its rhythm. The expansion continues, but the wild turbulence of earlier ages has softened into a slow, steady swell. Everywhere you look, galaxies gleam like jewels pinned to invisible threads of gravity. Yet something subtle is changing, something that even the galaxies haven't noticed yet. The light between them is stretching more quickly than before. Space itself, calm, obedient space, is accelerating. The culprit, though invisible, is everywhere around you. Dark energy, that quiet, relentless pressure pushing the cosmos apart, and you can almost feel it, like a deep exhale that never ends. You pass through a region of intergalactic space where the galaxies have begun to drift apart faster than gravity can pull them back. The great clusters remain intact for now, but the distances between clusters are widening. The expansion used to be slowing, cosmic gravity tugging inward against inertia, but now it's speeding up. Something unseen is rewriting the universe's long future. You tilt your perspective and the geometry of everything shifts. The fabric of space curves outward. Every photon, every atom, every bit of matter is being carried away by the invisible wind of acceleration. Historians still argue about what dark energy really is. Some say it's a property of space itself, an intrinsic pressure that comes with existence. Others think it's a new kind of field, like a ghostly cousin of gravity. A few even whisper that it might be the energy of the vacuum, the hum of quantum particles flickering in and out of being. Whatever it is, you can't escape it. It's smooth, omnipresent, and impossibly patient. If gravity is the universe's architect, dark energy is its expansionist poet, constantly whispering more. A quirky tidbit floats into your drifting thoughts. In '98, two teams of astronomers studying distant Type Ia supernovae accidentally stumbled upon this accelerating expansion. They expected to find that the universe was slowing down after the Big Bang, but instead the data said the opposite. The discovery shocked everyone. It was like measuring the speed of a car rolling uphill and finding it inexplicably accelerating. Since then, the numbers haven't lied. Dark energy makes up roughly 70% of all the energy in the universe. The rest, matter, light, everything you can see, is barely a footnote. You glide toward a vast cluster where galaxies still hold close to one another. For now, gravity wins here. The cluster's mass bends the surrounding light, warping the view behind it, a phenomenon called gravitational lensing. You can see distant galaxies stretched into luminous arcs, their shapes distorted by the invisible hand of mass. It's oddly beautiful, like light itself remembering that it can bend. These cosmic mirages are one of the few ways dark matter and dark energy reveal their presence, not directly, but by how they shape what you can see. Historians still debate whether the effects of dark energy are truly constant. Some believe it's unchanging, the same today as it was billions of years ago. Others suspect it evolves, a slow transformation in the very fabric of the vacuum. You look around and can't help but think it feels alive, adjusting itself with the same quiet intelligence that has guided every other cosmic transition. Perhaps dark energy is not a force to be understood, but a conversation, one the universe is having with itself about how to end gracefully. You pass beyond the cluster into the deeper dark. Here, galaxies are fewer and farther between, their light stretched thin by distance. The redshift grows stronger. The wavelengths of light elongate as space expands beneath them. Once blue stars now glow crimson. Once golden galaxies fade toward infrared. The farther you look, the older the light, and the more the universe's acceleration distorts it. You're witnessing not motion through space, but motion of space itself. It's not that galaxies are moving away from you. It's that the distance between everything is growing silently, inexorably. A curious detail. As the expansion accelerates, there will come a time, tens of billions of years from now, when distant galaxies slip beyond the cosmic horizon. Their light will no longer reach one another. To future observers, the universe will seem smaller, lonelier. They'll see only their own cluster, adrift in darkness, unaware that anything else ever existed. It's a melancholy thought, but you can't help admiring the poetry of saying, even the cosmos, vast as it is, will one day forget itself. You glide along a filament connecting two distant clusters, watching as its middle thins, the galaxies at either end slowly drifting apart. The thread stretches until it breaks, like taffy pulled too far. Gravity protests, but dark energy doesn't listen. The expansion is gentle but unstoppable, a sigh, not a scream. You imagine it as a cosmic lullaby, one that will someday fade all motion into stillness. Historians still argue what dark energy means for the ultimate fate of everything. Will it continue forever, pushing galaxies so far apart that stars exhaust their fuel in isolation? Or could it strengthen over time, tearing atoms themselves apart in a big rip? The data suggests stability, but nothing in the cosmos is guaranteed. You can feel the tension in the possibilities, like the pause before a final note. You pass through another galaxy, its stars shining in calm defiance. Within its spiral arms, new suns are still being born, oblivious to the cosmic acceleration outside. Life, if it exists here, has no reason to suspect the universe is slipping away beneath it. And maybe that's the point. Dark energy's touch is too soft to feel up close. You wonder if the beings that might one day evolve here will look to the stars and sense something missing, a faint sadness in the thinning light. You move onward, deeper into the accelerating night. The galaxies behind you stretch and dim, their light growing redder until it vanishes entirely. The cosmic hum softens. Even radiation seems to drift more slowly. You realize the universe is entering its long twilight, not an end, but an unhurried fading. Every motion, every spark, every whisper of gravity continues, just farther apart, slower, quieter, and as you float in that widening silence you feel both the melancholy and the magnificence of it. The universe doesn't rage against the fading of the light, it simply expands, endlessly, beautifully into peace. You travel onward, deeper into the unfolding quiet, where light feels stretched thin across eternity. The galaxies around you seem softer now, more distant, more reserved, as if they've accepted something you're only beginning to understand. The acceleration of space has separated them so far that the cosmic web itself looks faded at the edges, its filaments slackening like ancient silk. Clusters of galaxies that once gathered in gravitational camaraderie now begin to drift apart, each destined to become an isolated island in an expanding sea. The universe is not dying exactly, it's just learning solitude. You pass one such cluster, a rich collection of thousands of galaxies bound in a single gravitational well. Once, other clusters lay near enough to tug faintly on it to exchange stray galaxies and streams of gas. Now those neighbouring lights are slipping away, their glow reddened and dimming until it looks like embers through smoke. You realise you're watching the beginning of cosmic loneliness, the era when light itself grows too tired to cross the widening gulfs. If this cluster were alive, it would feel the ache of distance in its bones. Historians still argue how fast this isolation will proceed. Some models predict that within 100 billion years, every galaxy outside a local supercluster will have vanished from view, their light stretched beyond detection. Others insist the process will be slower, that faint remnants of radiation will linger for longer than thought. Yet the outcome is the same, the visible universe shrinking inward, like a lantern dimming in an ever-growing night. You can't help but think of it as a cosmic memory loss, each cluster forgetting that it was ever part of something larger. Within the cluster, life continues as usual for now. You drift past a spiral galaxy still forming stars, though more sparingly than before. Its arms are thinner, its dust cooler. The gas that once flowed freely through intergalactic space has mostly been spent or heated beyond usefulness. Star formation has slowed everywhere, the universe's great engine winding down. The colours of galaxies change with it. Where once they burned blue with youth, now they glow amber with maturity. The cosmic noon has long passed. This is the golden evening. A quirky tidbit surfaces in your wandering thoughts. Astronomers sometimes call this coming era the degenerate age, not because it's immoral, but because stars will eventually give way to degenerate remnants. White dwarfs, neutron stars, and band of black holes. The future will be lit less by the birth of new suns and more by the lingering embers of old ones. You glide through a field of such remnants, tiny white sparks scattered among the fading stars. Their light is faint, but oddly serene, like candles still burning after the feast has ended. Far away, a pair of galaxies near the cluster's edge are performing one last slow dance. Their arms intertwine in luminous ribbons, and after a few billion years they merge into a single, larger form. You can almost hear the sigh in their union, a weary but tender joining of what remains. Soon every galaxy in this cluster will do the same. Over eons they will merge and settle into one massive elliptical, a glowing city of ancient stars orbiting a supermassive black hole at its core. This will be the cluster's final act, contraction within expansion, an inward gathering as the outer universe drifts away. Historians still debate what role dark energy plays inside such bound systems. Some claim it has no influence once gravity dominates locally. Others suspect it still whispers even here, subtly reshaping orbits over incomprehensible timescales. You glance across the cluster and imagine those whispers, soft, patient, unavoidable. Perhaps dark energy isn't cruel. Perhaps it's simply the universe's way of ensuring that nothing becomes too crowded for too long. As you move outward from the cluster, the distances between galaxies widen perceptibly. Light travels longer, redder, weaker. You try to follow a beam from one bright spiral, but it fades before reaching the next galaxy. The photons themselves are stretched by expansion, their energy diluted into exhaustion. Even light is getting tired. It's not tragic, it's graceful, like a song ending on a note held so long it becomes silence. A curious thought, brushes through your awareness. There will come a time when observers inside one of these clusters will look out and see only their own galaxies, unaware that the rest of the universe ever existed. Without the clues of redshift or the cosmic microwave background, they'll conclude their cluster is the entirety of creation. The truth will have receded beyond reach, not erased, but veiled by distance and time. The universe will have folded its vastness inward like a secret. You drift beyond the edge of the cluster now, into the ever-widening void between structures. The darkness here feels heavier, like velvet pressed against your senses. Once, this space was filled with faint light from distant galaxies. Now, only the thinnest trace of radiation remains. The cosmic background itself, once a warm echo of the Big Bang, has cooled to near absolute zero. You listen for it and hear only a whisper, the faint static of creation's memory. Historians still argue whether there's comfort or sadness in this fate. Some see beauty in the idea of a universe stretching gracefully into silence. Others mourn the eventual loss of light, of contact, of a knowing. Floating here, you find both emotions blending into one. There's melancholy, yes, but also awe, because what you're witnessing is the universe's natural exhale, the gentle unwinding of a masterpiece that has already played its brightest notes. You look back one last time toward the cluster, still glowing, still vibrant in its corner of infinity. It will persist for trillions of years, its stars burning quietly long after everything else fades. And beyond it, the darkness grows, infinite and calm. The loneliness ahead isn't a punishment. It's the inevitable peace that follows creation's fever. The universe, it seems, was never meant to stay crowded. It was meant to open again, until even light learns to rest. You drift now into the luminous arms of a familiar galaxy, one you've circled countless times without ever truly seeing from this angle. The Milky Way stretches before you like a spiral of molten silk, its arms glimmering in blues, whites, and faint rose, each hue a record of stellar age and temperature. From above, it doesn't feel like a disk at all, but a vast whirling storm, its currents slow and hypnotic. The central bulge glows a warm gold, and beyond it, the spiral arms curve with almost mathematical grace. You can feel the quiet pulse of billions of suns, their combined light washing through you like the tide of an endless ocean. This is home, or at least the cosmic address where you'll find your home star someday. But right now, it's young, restless, and a bit messy. The Milky Way as you see it now is only a few billion years old. Its arms are uneven, studded with bright clusters and gaping voids. It's still in the act of defining itself, pulling gas from smaller galaxies nearby, sweeping up debris from collisions long forgotten. Every rotation takes about 230 million years, so if you could wait through one spin, entire species on future worlds would rise and vanish before the galaxy made a single twirl. Historians still argue about exactly how the Milky Way came together. Did it form smoothly from a rotating cloud of gas, or did it grow through mergers, absorbing smaller systems piece by piece? The evidence points toward both. The faint streams of stars that arc through its halo, stellar fossils, hint at a violent past. Each one is a ghostly scar left behind by a swallowed dwarf galaxy. Even now, the Milky Way continues its quiet feast. The Sagittarius dwarf, for instance, is in the process of being digested, its stars stretching into long ribbons that loop through the outer halo like cosmic fingerprints. A quirky tidbit to amuse you: our galaxy's name, Milky Way, comes from the Greek Galaxias kyklos, meaning milky circle. Ancient storytellers imagined it as a spilled stream of divine milk, or the path left by gods racing across the heavens. If only they knew the truth, that this spill was 100,000 light-years wide and home to hundreds of billions of stars. You can't help but smile at how human imagination, even when wrong, often lands near poetry. You descend into one of the spiral arms, the Orion Arm, a relatively quiet suburb in this galactic metropolis. Here, dust clouds twist lazily, forming the cradles of new stars. One of them, small and yellow, flickers to life about 4.6 billion years ago. Around it, a disk of gas begins to clump and spin. You watch the early solar system taking shape, planets forming like beads along invisible strings. Rocks collide and melt. Worlds are born, and in one corner of that disk, a modest blue sphere begins to shimmer with water and promise. You could almost reach out and feel the warmth of its first sunlight. Historians still debate exactly how common such planetary systems are. Once we thought our solar system might be unique. Now, thanks to telescopes that measure the faint dimming of distant stars, we know there are billions, perhaps trillions, of planets out there, some small and rocky like Earth, others gas giants or frozen orbs circling cold suns. You realise that in this single galaxy, the ingredients for life repeat endlessly like a theme the universe never tires of playing. As you rise above the galactic plane, the structure of the Milky Way comes into focus. The thin disk, where most stars live, floats inside a thicker halo filled with older, redder suns. Beyond that lies the dark matter halo, a vast, invisible cocoon that holds the galaxy together. It's strange to think that what you can't see outweighs what you can by a factor of 5. Gravity here is an artist sculpting light with an unseen hand. Every curve of the arms, every tilt of the disk, every orbit of every star owes its precision to that ghostly presence. A curious detail, the Milky Way hums, not with sound, but with motion. The stars oscillate slightly up and down as they orbit, like the strings of a plucked instrument. Even the spiral arms aren't stationary. They're density waves that ripple through the disk, compressing gas and sparking new generations of stars. You can feel that pulse, an eternal rhythm that beats every few 100 million years. If you could translate it into sound, it might resemble a heartbeat slowed to the tempo of eternity. Historians still argue about the galaxy's ultimate fate. Some predict that in 4 or 5 billion years it will collide with Andromeda, its nearest large neighbour. The two will merge into a single elliptical giant, perhaps named Milkomeda. Others think the process will be gentler, a long waltz rather than a crash. You look toward the distant horizon, where Andromeda already appears as a faint blur, and you can sense their inevitable attraction. Gravity doesn't rush, but it never forgets. Within the Milky Way, life stirs quietly on that tiny blue planet you glimpsed earlier. You can't see it yet, not really, but you feel its potential. The atoms forged in the cores of ancient stars have arranged themselves into oceans, mountains, and, eventually, beings who will one day look up and wonder where they came from. They'll name constellations, tell stories, build telescopes, and listen for the faint echoes of the Big Bang without realizing they're listening to their own origins. As you drift farther outward, the spiral arms of the Milky Way stretch below you like illuminated rivers. The galaxy turns, slow and sure, indifferent yet alive. It's just one among trillions, but it feels special, personal, perhaps because this is the one that will give rise to eyes capable of admiring it. You smile, or whatever drifting consciousnesses do, and realize that you're not just observing history. You're watching a home being built in the middle of forever. You linger near the Milky Way's shimmering edge, where the faint starlight thins into the soft dark of intergalactic space. From this vantage, your home galaxy looks tranquil, a serene spiral suspended in velvet black. But you know better. Inside, gravity is scheming again, planning its next great performance. Across the cosmic gulf, the Andromeda Galaxy glows faintly, moving toward us at a steady pace of about 110 kilometers per second. You can almost feel the inevitability in its approach. The two largest members of the local group are bound for an encounter so slow and so vast that, by the time it finishes, the very shape of both galaxies will have changed forever. You drift closer to Andromeda, tracing the delicate curve of its spiral arms. It is a magnificent neighbour, slightly larger, slightly brighter, like an older sibling who always seemed a little more composed. Its central bulge burns gold, surrounded by vast ribbons of dust and blue-white stars. Hundreds of globular clusters orbit it like bees around a hive. You imagine the Milky Way and Andromeda as two dancers circling across a ballroom of infinite darkness, each step pulled by the gravity of the other. Their meeting won't be an explosion, but a long, slow blending, a kind of cosmic courtship. Historians still argue when exactly this dance will begin. The best estimates place the first contact about 4 billion years from now, though some simulations suggest it might happen sooner. To human scales, that's impossibly far. To the cosmos, it's the next page in the calendar. The Andromeda-Milky Way collision will last billions of years, passing through several stages: approach, overlap, merger, and finally rest. Stars won't often collide, but their orbits will be thrown into graceful chaos, and great tidal streams of gas and dust will arc into space like ribbons caught in a cosmic breeze. You pass through the halo of the Milky Way, where some of this drama has already begun in miniature. Small satellite galaxies, tiny companion like the Sagittarius Dwarf and the Magellanic Clouds, spiral inward, feeding their stars to the larger system. You can see their trails faintly, glowing arcs of starlight that trace their slow demise. The process is almost tender, a quiet cannibalism that nourishes the greater whole. Even galaxies, it seems, grow by what they consume. A quirky tidbit: the Magellanic Clouds, those faint smudges visible from Earth's southern hemisphere, were once considered separate wanderers. In truth, they're bound satellites of our galaxy, connected by a river of hydrogen called the Magellanic Stream. That invisible bridge stretches across 600,000 light-years, a sign of the gravitational tension that will one day pull them fully into the Milky Way's disk. You drift along the stream, and it feels like following the vein of a sleeping giant. Back near the galactic core, the Milky Way's central black hole, Sagittarius A, waits quietly. It's small by cosmic standards, only about 4 million times the mass of the Sun, but it exerts influence far beyond its size. During the future collision, it and Andromeda's black hole will circle each other like predators, drawing closer with every pass until they merge in a gravitational crescendo. The resulting explosion of waves will ripple across space-time, a tremor so vast that even worlds yet unborn might someday detect its echo. You can almost hear it already, a low hum building under the cosmic silence. Historians still debate what the merged galaxy will look like. Some models predict a giant elliptical, smooth and featureless, its spiral arms erased by the turbulence of union. Others imagine a new hybrid structure, Milkomeda, a graceful blend of disk and bulge. From your vantage in the future, you see hints of both. The outer arms fade as stars scatter into wide orbits, but the core glows brighter, more concentrated, a golden heart surrounded by faint halos of debris. The chaos resolves into harmony again, as it always does. You drift through the merging system, watching stars slingshot in vast arcs as gravity reassigns their destinies. Two suns pass within a light year of each other, their gravitational fields warping space like ripples on a pond. You sense the slow ballet of orbits adjusting, entire solar systems migrating to new neighborhoods. In the midst of this grandeur, some small blue world, Earth's distant descendant perhaps, might still circle quietly, oblivious to the cosmic upheaval beyond its night sky. A curious fact about galactic collisions: despite the violence of the name, the probability of actual star-on-star impact is almost zero. The distances are simply too immense. Even when galaxies overlap, they mostly pass through one another like ghosts, their stars weaving new patterns in the aftermath. What really collides are their clouds of gas, and those collisions ignite spectacular waves of new star formation. You can see it now, great chains of blue-white suns forming in the wake of the merger, like fireworks tracing the path of the gravity's dance. Historians still argue what happens to the local group after this great joining. Will the smaller satellite galaxies be absorbed too, creating a single massive structure? Or will some drift away, unbound by the changing gravitational landscape? You look around and sense that the answer is both. Some will stay, weaving into the new galactic family. Others will wander into the deep dark, carrying the memories of their former homes as faint streaks of starlight. Eventually, billions of years after the first contact, the chaos subsides. The two black holes unite at the center, and the merged galaxy stabilizes. Its light glows softer now, a vast golden ellipse surrounded by a faint halo of ancient stars. The spiral arms are gone, but their legacy remains in every orbit, every quiet flicker of light. The Milky Way and Andromeda have ceased to be two, they are one, content and immense, drifting peacefully through an ever-widening void. You drift away from the glowing remnant, watching it shrink into distance. Behind you, space continues to stretch. The local cluster, this last island of matter, stands resilient against dark energy's pull, but everything beyond it has faded from sight. You realize that what remains is not emptiness, but the distilled essence of existence, matter clinging to itself in defiance of endless expansion. And you, still drifting, carry the light of both galaxies within you, a witness to their slow, beautiful reunion. You linger in the dim serenity of a future cosmos that has grown vast and mostly silent. The newly merged Milkomeda drifts at the center of its domain, surrounded by faint streams of stellar ghosts, the remnants of long-consumed satellites. Beyond this island of light, there are no nearby galaxies, no filaments, no cosmic web. Dark energy has stretched them all beyond the horizon. The sky around Milkomeda is nearly empty now, the stars no longer forming thick ribbons, but scattered like embers across infinite black. You hover in its outer halo, where gravity is still the quiet master, and realize that you're floating inside an invisible cocoon, one made entirely of dark matter. The halo extends far beyond the visible galaxy, a diffuse sphere of invisible mass that outweighs every star and planet combined. You can't see it, but you feel its pull, soft, omnidirectional, patient. This is the framework that has held galaxies together since the beginning, though its true nature remains a mystery even now. Dark matter neither shines nor absorbs light. It interacts through gravity alone, a silent skeleton supporting the luminous flesh of creation. The stars you see are just decorations on its bones. Historians still argue what dark matter truly is. Some think it's made of undiscovered particles, WIMPs, axions or sterile neutrinos, each a hypothetical ghost dancing beyond the reach of our instruments. Others believe it might not be matter at all, but a sign that gravity behaves differently on cosmic scales. For over a century, the debate has endured, fueled by the way galaxies spin faster than their visible mass should allow. Floating here, you can see that evidence everywhere. The stars on Milkomeda's outskirts orbit far too quickly to be held by starlight alone. Something unseen holds their path steady, like a conductor guiding an orchestra from behind a curtain. A quirky tidbit bubbles up from memory. In 1933, a Swiss astronomer named Fritz Zwicky was the first to notice this discrepancy while studying the Coma cluster. He called it Dunkel Materia, dark matter, probably not realizing he had named the most enduring mystery of the universe. Decades later, Vera Rubin would confirm the same strange behavior in the rotation curves of spiral galaxies, giving the idea permanence. You think of them now, those patient observers staring through telescopes, unknowingly peering into the architecture of existence. You drift deeper into Milkomeda's dark halo. And though you can't see it, you sense its texture. It's not smooth but clumpy, peppered with small concentrations of mass, subhalos they call them, remnants of galaxies devoured long ago. Around these invisible knots, faint streams of stars still orbit, the torn remains of ancient dwarfs. The light is faint, barely visible even to you, but each glimmer marks a history of collision and absorption. You realize that the dark matter halo is a kind of library, storing every gravitational event in its invisible geometry. Historians still debate how these halos formed in the first place. Did they arise from quantum fluctuations in the earliest universe, or from some unknown phase transition that froze invisible particles into place? Some simulations suggest the halos formed first, with ordinary matter falling into their wells to create galaxies inside. If that's true, then the light was always the follower, never the leader. The visible universe, the one of stars and planets, was merely the decoration on the invisible scaffolding laid down by dark matter. It's humbling to think that everything we can see has always depended on what we cannot. You glide outward, beyond the edge of Milkomeda's stellar disk, where the density of matter drops almost to nothing. The light from the galactic center is faint now, a golden smear across the black. Here, dark matter reigns alone, invisible but omnipresent. Its gravity still binds this galaxy, even as dark energy stretches the universe beyond recovery. You can sense the subtle competition between them, the inward pull of the unseen and the outward push of the void. For now, within this halo, gravity still wins. A curious fact: dark matter doesn't clump on the small scales the way ordinary matter does. It doesn't form stars, planets, or even dust. It's too aloof for that. Its interactions are rare, its temperament cool. That's why the universe's large-scale structure looks the way it does, smooth, web-like, and enduring. The luminous matter rides along those currents like foam on the crest of invisible waves. You imagine the halo as a gentle pulse, its gravity breathing quietly through the eons, steady long after starlight fades. You pause for a while, feeling the tranquility of this dark sea. The The stars of Milkomeda flicker below you, drifting in near-perfect orbits. Their light has turned redder now, their population's older, gas clouds are scarce, new star formation has slowed to almost nothing. The galaxy's glow is softer, its energy subdued. It feels like evening here, a long, infinite dusk. Historians still debate what happens when the last traces of gas are gone. Some say the galaxy will simply dim, each star burning its fuel until nothing but cinders remain. Others propose that dark matter might one day decay, releasing faint bursts of energy that will, for a fleeting moment, re-illuminate the universe. But no one knows. Dark matter has kept its secret for over 13 billion years, and it seems determined to keep it a while longer. You glance outward, toward the empty horizon. Beyond this halo, no light from other galaxies will ever arrive again. They have crossed the cosmological event horizon, lost forever to the accelerating expansion. Milkomeda, and the small handful of satellites still bound to it, is now the entire observable universe for any observer who might exist here. Everything else is gone, not in distance but in inaccessibility. Space itself is carrying the rest of creation away faster than light can follow. You drift back toward the galaxy's faint glow, and for a moment, it feels like a hearth in a cold room, warm, fragile, self-contained. Inside this single island of gravity, the legacy of the universe endures. Dark matter continues its silent vigil, holding everything together just long enough for memory to mean something. Perhaps that's its purpose, to give shape to the fleeting brilliance of light before the final calm sets in. You linger within the quiet halo of Milkomeda, and it's impossible not to feel the weight of history in every atom sun drifting around you. The galaxy glows softly, a solitary ember floating in the limitless dark. Yet even here, inside this lonely island, everything you see carries the memory of older fires. You reach out metaphorically and touch a grain of interstellar dust, no bigger than a mote, and realize it's made of ancient carbon and silicon, atoms born in the bellies of long-dead stars. Every element heavier than hydrogen is the child of catastrophe. The galaxy hums with those ghosts, the echoes of all its past explosions knitted into everything that remains. You drift closer to one aging star, its surface quivering faintly as it nears the end of its long burn. Its colour has shifted to a deep orange, the warmth of twilight. Within its core, the last reserves of hydrogen are fusing into helium, and soon it will shed its outer layers in a final radiant gesture. The gas will bloom into a planetary nebula, a fragile bubble glowing for just a moment before fading. The remnants of the star, carbon, oxygen, nitrogen, will scatter into the galaxy to be recycled once more into new stars, new planets, maybe new eyes that will look up and wonder. You float through that cloud and realize that in some far future chemistry, this is how memory survives. Historians still argue whether the elements of life formed mostly in supernovae, or in smaller, gentler deaths like this one. Some say the big explosions seeded the cosmos with iron and heavier metals, while these softer endings Gid-Simondias supplied the carbon and nitrogen vital for biology. Perhaps both are true. The universe has never been exclusive in its creativity. Every death feeds something else, every collapse sets the stage for a new kind of complexity. The galaxy, even now, is still writing its autobiography in atoms. A quirky tidbit for you, the gold in human jewellery, those thin rings and coins that gleam softly in candlelight originated in neutron star collisions. When two of those ultra-dense remnants spiral together, the impact releases conditions fierce enough to forge gold, platinum, and other rare elements. It's strange to think that something so delicate and precious was once spat out by an explosion that could shatter galaxies. The atoms that humans one day polish and cherish were born in some of the loudest moments the universe has ever known. You pass through a region where an older generation of stars has long since gone cold. Some are white dwarfs, dense, dying embers that still glow faintly from residual heat. Others have collapsed into neutron stars, their gravity so immense that atomic nuclei themselves have fused. A few, invisible and absolute, are black holes, tiny points of silence scattered like punctuation marks across the galactic story. You sense their presence rather than see them, each one a reminder that even the most brilliant light eventually folds inward. And yet the debris they leave behind, dust, gas, and heavy elements, forms the seeds of new beginnings. Historians still debate why the universe chose such an elaborate cycle of creation and decay. Was it mere physics or something deeper, a kind of efficiency written into the fabric of nature? The answer doesn't come easily, but drifting here, you sense its simplicity. Nothing in the universe is wasted. Even the ashes of stars find purpose. The calcium in bones, the iron in blood, the oxygen in every breath, all of it was once part of a star like the one you just watched fade. The universe builds itself from its own ruins. You glide toward one of the galaxy's remaining star-forming regions, nebula glowing faintly pink and blue against the night. Star formation has slowed over billions of years, but it hasn't stopped entirely. Inside, gravity still weaves gas into knots, and within those knots, pressure kindles the spark of fusion. You watch as a new star ignites, a pale sun that will burn for trillions of years, far longer than the one that once warmed your home planet. Around it, dust and gas spiral into a flattened disk, colliding and merging into larger pieces. The first outlines of planets begin to take shape. You wonder whether some distant future consciousness might rise beneath those newborn skies, never knowing how ancient its ingredients truly are. A curious note. Even now, scientists on that old blue world, long gone perhaps, still argued about the odds of life elsewhere. Some insisted it was inevitable. Others called it a cosmic miracle. But as you drift here, watching chemistry repeat its slow, patient dance, it seems almost certain. Life, after all, is just another way the universe recycles energy and structure. Given enough time, even hydrogen finds a way to become aware. You move farther out, past the nebula, and gaze across the galaxy's dim, reddish glow. The Milky of this era feels different, calmer, older, but not lifeless. It's a monument built from memory, every atom a story, every photon a relic. The stars are fewer now, but each one carries within it the materials of thousands of ancestors. You realise that the universe has been keeping a kind of ledger all along, balancing every birth with a death, every flame with an ember. Historians still debate whether this persistence has meaning, or whether it's simply the side effect of physics running its course. Maybe meaning itself is just another form of structure, an emergent property of atoms arranged the right way. You can't decide which answer is more comforting, that the universe is indifferent, or that it keeps telling the same story because it secretly enjoys the plot. You pause near the edge of a globular cluster, its ancient stars glowing like a pocket full of gold dust. Many of them have been burning since the universe was young. They've seen it all, the first galaxies, the reionization of space, the slow dimming of the light. Their composition carries traces of every cosmic generation before them. You look at them and feel a strange kinship. After all, every molecule in you, every spark of consciousness that allows you to float and think, was born from this same furnace. The stars are not just distant, they are your ancestors. You drift through the faint starlight, and for a long, quiet moment, everything feels connected. The dust, the stars, the future, the silence. The galaxy glows behind you, a memory of everything that ever was, and the darkness ahead opens like an invitation. You realize that even when light fades, the story continues, written in atoms, in gravity, in the quiet hum of what remains. The echoes of creation are still here, in you, in everything. The universe remembers itself through you. You drift now into the realm of thought rather than light, slipping through epochs when the universe is too old for easy spectacle. The galaxies are few, the distances between them too wide for even patience to cross. But consciousness of a kind still persists. Not the warm-blooded, oxygen-breathing curiosity that once looked up from a blue planet, but patterns in plasma, magnetic minds flickering in the atmospheres of long-lived red dwarfs, or digital echoes stored in machines orbiting dying suns. And even among those quiet intelligences, one obsession remains, understanding how it all began. You ease closer to one such remnant civilization, huddled around a star whose light is faint but steady, where scientists still run simulations of the universe's birth on computers the size of moons. Inside their calculations, you watch miniature universes unfold, tiny digital Big Bangs blooming in a vacuum of pure math. These beings don't see the cosmos as a cold, empty expanse, but as an experiment still running, its parameters slowly shifting under the influence of dark energy. Their simulations replay the cosmic history you've just witnessed, the first flickers of starlight, the gathering of galaxies, the quiet acceleration that followed. They whisper theories about what came before and what might come after. Some of them believe the universe will end in slow decay, others imagine it collapsing back into a singularity ready to start again. You, floating unseen, almost smile at their persistence. Even at the end of time, curiosity survives. Historians still argue, even among these descendants of descendants, whether the universe had a true beginning at all. Some favour the cyclic model, an eternal rhythm of expansion and collapse like the cosmic equivalent of breathing. Others think the multiverse is real, countless universes budding off from one another, each with its own laws of physics. To them, the Big Bang wasn't an origin, but an inheritance, a continuation of something older than space itself. Watching their holographic projections of bubble universes colliding and merging, you can almost hear the echoes of philosophers from Earth's forgotten ages, asking the same questions beneath very different skies. A quirky tidbit endures even here. In these distant epochs, the data from the earliest telescopes, Hubble, Webb, and their kin, still exist, preserved as sacred relics. The ancient images of faint red galaxies, the glow of the cosmic microwave background, the first hints of dark matter filaments, they treat them as scripture. Those photographs, billions of years old, are the last shared memories of a time when the universe was crowded and bright. You drift through one of their archives and see those images projected in light, a universe half forgotten, but still adored. Outside, the cosmos continues to stretch. The night between galaxies grows darker and more absolute. From this late vantage, light itself has become rare. The cosmic microwave background has redshifted into radio waves so long that no receiver can detect them. Even quantum fluctuations have thinned. You can feel entropy rising like a slow tide, erasing gradients, evening out the last differences. The universe is moving toward thermal equilibrium, a phrase that sounds dull, but really means peace. Everything is balancing, slowly, quietly, eternally. Historians still debate how long stars like this one, small, red, enduring, can keep shining. The estimates run into trillions of years. Compared to them, the sun was a mayfly. These red dwarfs sip their hydrogen so frugally that they outlast almost everything else. When they finally die, they fade into black dwarfs, objects so cool they emit no visible light. You pass near one, and it looks like nothing, a dark pebble suspended in perfect silence. Touching it would be like pressing your hand to the concept of sleep itself, a curious fact that comforts you. Even in this era, collisions still happen, rarely but not never. Brown dwarfs, failed stars, sometimes merge, briefly reigniting fusion for a few thousand years before settling back into darkness. For that short while, they light up their corners of space, tiny lanterns in the endless dark. You glide past one such flare, a newborn sun's ghost, and feel warmth that seems impossibly tender against the cold of the future. The universe hasn't forgotten how to create, it's just learned restraint. You wander into a region where gravity itself feels looser. Dark energy's dominance is nearly total now, and even within Milkomeda's halo, the faint tug of expansion can be felt. The galaxy's outer stars have drifted too far to remain bound. They are falling outward, their orbits dissolving into the cosmic current. You watch one star drift away, carrying with it whatever planets may have circled it, whatever stories might have been written there. The light weakens until it disappears completely. For a moment, you imagine that single star still believing it belongs somewhere, unaware it's now alone forever. Historians still argue whether information, every particle's position, every photon's path, can ever truly vanish. Quantum physics insists it cannot. General relativity seems to disagree. Perhaps somewhere in the mathematics that binds both, there's an answer waiting to be seen. You think about that as you drift between black dwarves and fading red suns, as the universe cools and slows and forgets. Maybe nothing is truly lost. Maybe every vibration, every word ever spoken, still ripples faintly in the fabric of time, too faint to detect but too stubborn to die. You pass a region once rich with stars and find only quiet now. The last flickers of light wink out one by one, like candles extinguished after a vigil. Yet the atoms remain: hydrogen, helium, iron, carbon, scattered but not destroyed. You can sense the ghost of starlight still clinging to them, the faint warmth of the memory. Perhaps someday, if the universe cycles again, these atoms will gather once more and ignite. Perhaps the next cosmos will glow from the ashes of this one. A thought, delicate and persistent, finds you here in the dark. You are never just observing the birth of galaxies. You are watching the universe learn consciousness, one atom at a time. Every star that formed, every molecule that thought, every civilization that dreamed, all were the universe reflecting on itself. And though the lights are going out, that reflection endures. It's written in the structure of space, in the quantum threads of what once was. You linger in that awareness for a long while, feeling neither sadness nor triumph, only stillness. The galaxies are gone, the starlight faded, but something remains, the knowledge that it all happened, that it mattered, that the universe once looked inward and saw itself. You are that remembrance now. You always were. You drift through the last epoch of time, when even silence seems old. The universe has become a cathedral of stillness, every echo long spent. The galaxies are gone now, dissolved, merged, or stretched beyond reach. Only scattered remnants remain, black dwarfs, neutron stars cooled to crystal, and black holes quietly haunting the dark. The temperature of space has dropped so close to absolute zero that motion itself feels like a rumour. You can sense time here, but it no longer moves with rhythm. It stretches thin, syrup slow, each second as wide as an ocean. This is the long twilight of everything, and yet strangely it's beautiful. You hover near one of the last black holes, a behemoth that once anchored an entire galaxy. For trillions of years it devoured matter and radiated energy through friction and gravitational waves. Now, starved and isolated, it glows faintly with Hawking radiation, the last whisper of quantum mechanics at work. The light it emits is weak but persistent, each photon a tiny act of defiance against oblivion. You drift closer and can almost feel the paradox, gravity and quantum theory locked in a final conversation. Even here, physics keeps arguing with itself politely, endlessly. Historians, or what remains of them, still debate what happens when the last black hole evaporates. Some claim that Hawking radiation carries away every ounce of its mass, leaving only a burst of particles before nothing remains. Others believe the information once trapped inside will leak back out, encoded in the radiation, preserving the universe's memory in its dying breath. Floating here, you can't help but imagine that final release, like a sigh across eternity, as the last piece of matter becomes light once more. A quirky tidbit persists in the whispers of late-time theorists. They call this the black hole era, though calling it an era feels generous. It lasts for 100 years or more, a duration so vast it mocks the concept of measurement. In that time, black holes slowly shrink, their energy bleeding into the vacuum until even they fade. When the last one goes, there will be no more structure, no more heat, no more difference between one point in space and another. Everything will be uniform, a perfect, absolute calm. The universe will have reached thermodynamic equilibrium, the long-promised end of entropy's story. You drift away from the dying black hole, through space so empty it might as well not exist. Occasionally a particle flashes into being, a virtual fluctuation that appears and disappears before it can be noticed. The quantum foam still murmurs, faintly like the static between radio stations. It's not nothing, it's possibility. The tiniest reminder that even void isn't truly void. You realise with a kind of peace that the universe can never be completely still. Existence itself is restless, forever whispering the idea of itself into the dark. Historians, if that word still applies, used to argue about how this story might end. Some proposed the Big Rip, where dark energy's expansion tears even atoms apart. Others imagined a Big Crunch, where gravity reclaims everything in one final collapse. But the evidence now points to a quieter ending, a slow fade into uniformity. It's not dramatic, it's graceful. The universe doesn't die screaming, it exhales softly, until the only thing left is space expanding into itself. You pass through the final traces of matter, a few drifting electrons. A handful of photons stretched to wavelengths longer than galaxies once were. Their energy is so faint it barely counts, yet you can feel their persistence. They are the last voices of the Big Bang, stretched thin but unbroken. Even after everything else has gone silent, these photons keep singing, an endless hymn to the idea that something once was. A curious fact lingers from the old days. Heat death, as the name suggests, isn't death at all. It's balance. Every energy gradient erased, every potential satisfied. In human terms, it sounds tragic, but to the universe it's serenity. There's no more struggle, no more asymmetry. Even time loses meaning because there are no events left to separate one moment from another. It's not nothing, it's completion. You drift through this completion and find yourself wondering whether consciousness, any consciousness, could exist here. Without stars, without atoms, what would a mind even be made of? Perhaps patterns of vacuum fluctuations or networks of quantum entanglements stretched across what remains. Maybe the universe itself is dreaming now, reflecting on its own story through you. Maybe that's all you ever were, a thought the cosmos had about itself, persisting until the last possible moment. Historians still argued, even near their end, whether time would ever truly stop. Some said the expansion would continue forever, making everything infinitely dilute but never frozen. Others thought quantum decay would end even the fabric of space-time. You can't tell which is right anymore, and maybe it doesn't matter. What you know is that stillness doesn't mean absence. It feels more like rest. The last particles fade. The final black hole evaporates with a quiet burst of radiation that vanishes into infinity. The universe, vast and calm, is now only space expanding without purpose or pain. But even in that calm, something lingers, a pattern, faint but undeniable. Perhaps it's memory, perhaps it's you. And so the quiet birth of galaxies ends not with silence, but with a soft hum beneath nothingness, a reminder that creation never really stopped. It only changed form. The universe has fallen asleep, not dead but dreaming, its vast mind at peace after eons of motion. You drift once more through that infinite calm, carrying with you the echo of every star, every atom, every thought that ever was. The darkness embraces you gently, and for the first time there is no before or after. Only stillness, only home. And now, after our long journey through creation and calm, let's slow everything down together. The universe has finished its symphony, and we've listened to every note, from the first trembling spark to the final fading hum. You've watched galaxies breathe, stars awaken and die, black holes whisper, and time itself softened into peace. And somewhere in all of that, you found a rhythm that felt familiar, because it's the same rhythm that hums quietly inside you. So as you breathe now, imagine that breath as the echo of the cosmos expanding and contracting, the same ancient pulse that gave rise to everything you've ever loved or wondered about. The light that once crossed galaxies now rests behind your closed eyes, a soft, endless glow that asks for nothing but calm. The universe is resting, and so are you. The stars have gone quiet, the galaxies have fallen still, and there's nothing left to chase. You've travelled far enough, everything is gentle here. And the dark isn't frightening anymore. It's simply warm, soft, infinite. Let go of what's distant. Let the thought of gravity fade. The cosmos has exhaled, and you can too, drift a little deeper. The sound you hear, the one just under your breathing, is the last heartbeat of the universe, steady and slow. It's been waiting for you to notice it. And now, as the final light folds into darkness, remember, it's not an ending, it's a rest. Sleep well, traveller of the stars, the universe is quiet now, you can be too.